Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to discuss policy based routing. Till now we had discussed the routing protocol like EIGRP, OSPF, BGP, ISIS, all routing protocols. You know, in all routing protocols, router forward traffic on the basis of destination IP address. Like here in this topology, as you can see, router 1 have two paths to reach in this network in 10.1.20.0/24 network, because here we are running EIGRP, but the bandwidth of upper link is 2 Mbps and bandwidth of lower link is 1 Mbps. So router 1 will choose which path? Upper path to forward all traffic. Yes or no? Here you can see I have two IP phone 1 and IP phone 2. As you know, IP phone is going to send voice over IP data, and voice over IP data is delay sensitive data, right? Bandwidth is not important for voice over IP, right? To send data of IP phone from this phone to this phone, let's say voice data, for that bandwidth is not important. Delay is important. If this phone is sending one voice data from this phone to this phone, so reply should be received within 150 millisecond. So delay is important for voice data and bandwidth is important for data, for the normal data traffic. Okay, so by default router will perform, you know, router will actually choose this path, upper path, only to forward traffic of PC as well as IP phone. But what I want, if I want to forward the traffic of IP phone from the lower path, and EIGRP should work fine, it should forward all other traffic, all rest traffic through router number 2 only by using upper path. But the traffic of voice should be forwarded by a router through lower path, means router 1 should forward it to router number 3. But in the normal behavior, if I will talk about the normal forwarding, so when this user, or let's say this PC will ping to this PC, source IP address will be 192.168.10.10, because 10.10 is the IP address of this machine, and destination IP will be the IP address of this machine, 192.168.20.10. When router 1 will receive it, router 1 will check their routing table. In their routing table, in the routing table of router 1, you can see there is one entry. So IP route, let's say EIGRP, to filter the routing table. See, the route is available 192.168.20.0/24. This one is AD value and this one is metric, and reachable via 12.1.1.2. So next hop IP address is 12.1.1.2. That means IP address of router 2. You know, between routers I am running IP address like, see, between router 1 and router 2 I am using 12 network. I am using 12 network because router 1 and router 2, so I am taking 12.1.1.0/24. On router number 1 I am configuring 12.1, and on router number 2 I have configured 12.2. In the same way, between router 2 and router 4 I am using 24.1.1.0/24 network. Here I have configured 24.2 and here I have configured 24.4. Between routers I have configured IP addressing like this. But this is my LAN and this one is another LAN. In each LAN we have one IP phone, and my requirement is all voice traffic should be forwarded by a router via router number 3. Then we need what? PVR, policy based routing. Policy based routing. We can use lower path for the voice, but by default EIGRP will use upper path for all traffic, right? So actually we need to divide the path for voice and data. Here I want to divide the path for voice and data. So how we can achieve it? How we can divide the path? With the help of policy based routing, with the help of PVR. In PVR, PVR provides path on the basis of data type actually, right? So PVR is going to decide the path on the basis of data type. And normal routing protocol like EIGRP is going to decide the path on the basis of destination IP address. To forward traffic, router 1 is going to check only destination IP address. Destination IP address is matching in this network, it will forward it to router number 2. But in PVR we can apply policy for some specific data like TCP data, like UDP data. We can match the source IP address, we can match the destination IP address, we can match the source port number, we can match the source destination port number. Like this we can perform the routing, and that is nothing but the policy based routing. I will show you the configuration also, guys, don't worry. Actually, in policy based routing, we don't forward traffic on the basis of destination IP address. We don't forward traffic on the basis of destination IP address like a normal forwarding. In normal forwarding, router forward traffic on the basis of destination IP address, but in the PVR we will forward traffic on the basis of source IP also, destination IP also, source port, destination port, like this. Okay, so if I will talk about the normal forwarding, normal forwarding, so router is going to check only destination. But if I will talk about the PVR policy based routing, it is going to check source IP, it is going to check destination IP, it is going to check the protocol value, it is going to check source port, it is going to check destination port. That means PVR will perform routing on the basis of traffic type. Done, guys. Now question is very important, and that is how to identify the traffic, how PVR is going to identify the traffic. For the identification or for the classification we have two way. First one is access control list, ACL. Here we will not configure ACL to deny or allow the traffic. Here we are using ACL for the classification of traffic. Done. After that, the second way is length. I will configure each one by one. First, I will show you the PVR configuration with ACL. Then I will show you the PVR configuration with length. If traffic will not match in the PVR, see, first of all, what will happen now? Now here, let's say I have configured one PVR on router number 1. So whenever router 1 will receive any traffic, first of all it is going to check what policy. It is going to check policy. If policy will match, yes, then it is going to forward traffic through PVR. If policy will not match, then it is going to check what routing table, normal forwarding, routing table, and that is normal forwarding. And if in the routing table router will not match, then it will drop the traffic. Definitely you know that. Yes. If in the routing table router will not match any entry, then it will drop the traffic. Right. So if router will match the entry in the routing table, then normal forwarding will happen. If policy will match, first it is going to check what policy. If policy will match, then traffic forwarding will happen on the basis of PVR. If PV policy will not match, then it is going to check the routing table. In the routing table, if route will match, then router will forward normal forwarding, and if route will not match, then it will drop the traffic. Now question is how to configure. So configuration is very basic, guys. Here on router number 1 you will configure one access control list, IP access list extended. After that, name of access list is, let's say, what, A. Name of access control list is A. And here we are going to define the permit IP, and here you can say TCP as well. I am going to use the IP protocol directly. So permit IP host, let's say 192.168.10.20 is the IP address of IP phone 1. Actually, I want to forward voice traffic through lower path and data traffic through upper path. Done. So host will be this one, and the destination host is, you can say any as well, and you can say you can provide the network ID of the destination, that 192.168.20.0 wildcard mask 0.0.0.255. Like this we have configured the access control list. In the access control list I match the IP address, right, IP address of IP phone, and now I am going to create one route map, and name of route map is, let's say, my policy. I have created one route map with name my policy, and permit sequence number is, let's say, 10, and you can avoid this thing as well. Automatically it will take sequence number what, 10. After that, in route map I am going to say match IP address from access list A. So it will match this IP address, yes or no. And then I am going to say set next hop, set IP next hop, IP next hop 13.1.1.3. This is the IP address of router number 3. After that, I will apply this policy on the interface. On which interface? On this interface, on the incoming interface. Policy will work only on incoming interface, right? So here interface F0/0, and here I am going to apply the access control, sorry, the policy. So command will be IP policy, after that route map, and then name of policy is my policy. Done. This is the configuration, very easy. After that, there are some verification command like show IP policy, you can debug the policy, show IP route map. Okay, now guys, let me show you the configuration step by step. See, first of all, on router number 1, there is only one path in the routing table of router 1, that is via router number 2. If you will check topology table, so IP EAGRP topology table and all links say. So you can see there is two paths available for this destination, via router number 2 also and via router number 3 also. But EAGRP calculate their metric on the basis of bandwidth, delay. So that's why you can see metric through upper path is lower than metric of lower path. Metric of upper path is lower than metric of upper path. That's why upper path is best path. Now, if this PC will ping, which router 1 will use which path? Via router number 2. Yes or no? Now guys, I am going to configure the policy over here. So first of all, I will create the access control list IP access list. After that, name is, let's say, A, name of, and here we need to say extended as well, extended, and name is A. After that, permit IP host, and IP address of host is 192.168.10.20. After that, if you will put question mark, it is asking for destination. So destination is, let's say, complete network 192.160. Or if you want, let's say, my requirement is that when this IP phone communicate with this IP phone, in that scenario only router should use lower path. So I will define destination also as host. So destination is also what? Host, and IP address is 192.168.20.20. Done. I have created the access control list. Now I will create one route map, and name of route map is, let's say, my policy permit 10. And if you don't want to configure the sequence number, so you can leave it as well. Done. Here I am going to say match IP address from list number A, from access list A, and set IP next hop 13.1.1.3 is the IP address of router 3. Done. After that, I will apply this policy on interface F0/0. So interface F0/0. Here I will run command IP policy route map and name of your route map is my policy. Done. This is the configuration. Now if you want to verify, so you can run command show IP policy. So here you can see I have created one policy on F0/0 and name of that policy is my policy. If you want to check the route map, you can check route map, so route map. So there is one route map, and how many match is there? 0 match. 0 match. Done. Now what I am going to do, guys, I am going to debug IP policy. I have enabled the debugging. Now from router PC number 1, I am going to send some traffic to PC number 2. So let me take you on PC number 1. Here let me assign the IP address. IP 192.168.10.10/24 and gateway is 192.168.10.100. Done. When this PC will ping, PC number 1 will ping to PC 2, that time tell me policy will match or not. Policy will not match, so router will perform normal forwarding. Yes or no? Let me ping 192.168.20.10, and before that I need to configure IP address on 20 as well. IP 20.10/24 192.168.20.100 is the gateway. What happened? IP 192.168.20.10/24 and gateway is this one. It's a duplicate IP address over here. Let me check the IP configuration of router 4. Maybe on router 4 I have configured 10. Yeah, duplicate address. Here also I am getting the error. So here I need to configure 100 on the LAN interface. Interface F2/0 IP address is 192.168.20.100 255.255.255.0. Done. Now let me take you on PC number 2. Again I am going to configure the IP. Now this time IP configuration is done. Now I am going to ping from PC 1 to PC 2 and see ping is fine. Here you can see in the log message I have enabled the debugging, so you can see source is 192.168.10.10 and destination is 192.168.10.20.10 and it's FIV. It is forwarding traffic through FIV table. Policy rejected, no match, and it's taking normal forwarding, right? So this time actually my policy is rejected because policy does not match. If you will check the route map, so route map, you can see match is still what? 0 packets, 0 byte. So when policy will not match, router is going to forward traffic through normal forwarding, through FIV table, through EIGRP, through upper path. Yes or no? So EIGRP is still working fine. We don't need to do anything with EIGRP. Now I am going to configure the IP address on IP phone. Let me configure first on IP phone 1. This is also PC. Just consider that this one is an IP phone 192.168. Or if you want to take IP phone, so you can perform practical in packet tracer. Here we need to add image 10.20/24 and gateway is 192.168.10.100, right? In the same way, I'm going to configure IP on this PC, sorry, this IP phone, IP 192.168.20.20/24 and 192.168.10.20.100 is the gateway. Okay, now I am going to forward traffic from IP phone 1 to IP phone 2. Ping 192.168.20.20, and before it, let me check debugging is enabled or not. Yes, debugging is enabled over here on router number 1. So let me ping. Ping is working, and see on router number 1 the message. Source is 192.168.20.20 and destination is 192.168.20.20. 10.20 and 20.20. This time FIB policy match. You can see IP policy match, and this time forwarding is happening on the basis of PVR, policy based routing. And if you will check the route map, there also you can see the match. So route map, 5 packets match for 490 bytes. Done, guys. So when source is this one, destination is this one, this time policy is matching and forwarding is happening on the basis of PVR content. PVR content, here you can see traffic is forwarded through PVR. Done. So now hope it's clear, guys. Hope this is clear to you. This was the policy based routing configuration through access control list. Now I am going to remove this configuration and I am going to show you the policy based configuration on the basis of length. As I told you, we have two ways to classify the traffic. First one is length and second one is access control list. So here in route map, and name of route map is my policy, and here I am going to say no match IP address from access list A. Done. Okay, you can remove access control list also. No IP access control list, access list extended A. Now you can verify. So access list, there is no any access control list. So route map, in the route map there is no any match. Now what I am going to do, I am going to see if now you will forward traffic from PC or IP phone, it will happen through normal forwarding. See, from from IP phone 1 I am going to ping again. See, policy it's showing policy match. Policy should be rejected over here now. So IP policy on interface, my policy is configured, and so route map set next of IP address, this one, and there is no any match, so it will match all. So if you will forward traffic from PC number 1 also, then also you can see policy match. Yes or no? Because in the route map, if you will not define any match entry, so it will match all. So for all traffic now, Now PVR will perform routing. For all traffic, PVR will perform routing. Now I am going to match what length. Now I am going to match the length of traffic. Say route map. After that name is my policy. And here I am going to say match length. Length. Match those traffic whose length is starting from 100 and whose length is ending from at 200 byte. So all the traffic whose length is between 100 and 200, for those traffic will match in the route map. For those traffic policy will work, and for rest traffic policy will not work. Done. Now see, here I am going to send ping again, and this time see policy is rejected and normal forwarding. Policy is rejected and normal forwarding. Router is forwarding the traffic by checking their routing table. Done. Now here I am going to define the length. I am going to define the length. Say, let's say 150. See, this time policy will match. You can see policy match, and it is forwarding traffic through PVR. Through PVR. Done. So route map. Match is also, you can see 20 packet and 2430 byte. Done. If I will ping again, so match will increase. Now it's 20 packet. And now you can see the route map. Match is 25 packets. But if length of traffic is more than 200, let's say 250, then policy will not match. Policy rejected. Normal forwarding, you can see policy rejected. No match. Normal forwarding. And so route map. Here also you can see packet match is only 25 packets. So done, guys. This is the two way to configure to classify the traffic. In next video, I will make you understand the local policy configuration and the default PVR. We have some more concept in PVR, so we will discuss that also in next video. Then I will show you some troubleshooting ticket as well. Okay guys, but if you have learned something from this video, please hit on like button. If you have not subscribed this channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye guys.